welcome back. This is the last of the lessons on areas and volumes, or to be honest, on integration, which I am recording. I took the hardest of the lot in the end. You might have seen before the wristwatch was invented or the clocks were invented, we had the sand timer. The shape of the sand timer is an hourglass, they call it as. So like, they would put every hour. You keep flipping it over, right? So this particular graph shows the shape of the hourglass. So now the first part says sketch the curve. It's a curve. Remember when your teachers taught you parametric equations, and or when you looked at the video, when you watched the video I did on parametric equations, it was a trigonometric function. Sketch the graph from 0 to pi, or 0 to pi, and then or pi over 2, and then you use the properties of sine and cos to sketch it. To complete the graph. So let's see. So t is 0, pi over 6, pi over 4, pi over 3, pi over 2. I think that should be enough for me. What is x? Equal to sine 2t and a sine t, a sine 2t. What are the values? 0, 0, half a, and root 3 over 2a. Pi over 4 is root 2 over 2a, and then pi over 2 is a. And then pi over 3 is root 3 over 2a. 2 pi by 3 is also root 3 over 2a. Pi over 2 is a, pi is 0. So, as t increases from 0 to pi over 2, the values of x go from 0 to a, the values of y go from 0 to a and back to 0. Very interesting. So in other words, my whole graph is confined to, see, the range of the function. The domain is also a, because minus a to plus a, the range is also minus a to plus a. So therefore I am restricting it there. Let's say this is a, and then this is 0.2, 0.4, 0.6, 0.8, 0.2, 0.4, 0.6, 0.8, 0.2, 0.4, 0.6, 0.8, 0.2, 0.4, 0.6, 0.8. Roughly doesn't matter. That's an A, that's a minus A, that's a minus A. You start at 0, 0, 0.5A and 0.866A. So 0.5 and 0.866. And then 0.7 and A. X is A and 0.7. 0.6, 0.7. And then 0.866. Oops, what am I talking of? X is idiot. X is 0.7, Y is A. And then 0.866, and then 0.866, and A 0. So do you agree this graph goes like that? What happens as t goes? So this is t equal to 0, that's t equal to pi over 2. Yeah. What happens afterwards? As t increases from 90 to 180, it starts from A, goes back to 0. It will come back here. Whereas this one starts on negative root 3 over 2a, negative a, negative root 3 over 2a, 0. So, by symmetry, that graph goes somewhere like that. So common sense tells you it goes like that, and then it goes like this. That's the hourglass. Very nice. That's your graph. To find, therefore, let me try a rough sketch here. So I think you get about 3 marks to sketch that graph. So I will draw the sketch on the other side because I need the sketch. So I will just draw the sketch there for my own interest. Oh my God, my sketch is horrible, isn't it? Sketch the curve. Somewhere like that. This is t equal to 0, t equal to pi over 2, then t equal to pi, t equal to 3 pi by 2, t equal to 2 pi. Now let's look at that area. That is A. So the total area is, I hope this pen writes, is, look, 1, 2, 3, 4. 4 integral 0 to a y dx. Yeah. Always write in terms of x and y. Y is a sine 2t. dx by dt is a cos t. So dx equal to a cos t dt. Okay. X is equal to a sine t. T equal to 0. Sorry. X equal to 0. A equal to 0. T equal to 0. X equal to a. T equal to pi over 2. So put all that. So it becomes 4 integral 0 to pi over 2 a sine 2t times a cos t dt. Always write in terms of y and x and then change it to, okay, let's see if this works. So that is 4a squared integral 0 to pi over 2 sine 2t cos t dt. There are 2 or 3 different ways of doing this. Depending upon the time, I'll have to decide which is the best. 7 minutes, so I can do it. I will show all the methods. I'm going over various methods of integrating trig functions. I'll put method 1. Is 4a squared integral 0 to pi over 2 sine t cos squared t dt. Yeah, because sine 2 theta is 2 sine theta cos theta, cos and cos becomes cos squared. When you differentiate a cos, you get a sine, but a minus sign. So I'll put minus 8a squared 0 to pi over 2 cos squared t times minus sine t dt. I am using inspection, but if you are not happy with inspection, please use u equal to cos t. Don't bother about the limits, then you can do it. So that is minus 8a squared times cos cube t over 3 between 0 and pi over 2. So that will be minus 8a squared times cos of pi over 2 is 0 minus 1/3. So it is 8a squared over 3. Yeah. I want to show you method 2. Just showing off. Trigonometry, that's the beauty. You can do it in so many ways. Instead, can I write this as 2a squared integral 0 to pi over 2 2 sine 2t cos t dt. What is 2 sine a cos b? 2 sin A cos B is sin of A plus B plus sin of A minus B. So that is 2A squared integral 0 to pi over 2. In place of A, I have 2t. In place of B, I have t. 2t plus t is 3 sin 3t plus sin t dt. So that is minus 2a squared times, okay, sorry, let's do it. I don't want to jump the gun. So 2a squared times minus cos 3t over 3 minus cos t between the limits 0 and pi over 2. Okay. Let's now put in the limits. It is 2a squared over 3 times 0 minus 0 minus minus 1/3. Cos of 0 is, minus 1/3 minus 1. So it is 2a squared over 3. Why am I saying over 3? 2a squared times 4 over 3, which is 8a squared over 3. So, same answer. So, you can do it this way or the other way. Next comes an hourglass. I think if you watch some of the old videos or TV series, you'll see it's like this. You have something like this, and you have sand here, and then sand pours here. Yeah, and you keep flipping up. I want to find the volume. So what I do is, if I take this region and rotate it, I get that volume. Double it, I get the other volume. Yeah. So therefore, it doesn't matter the symmetry, the volume does not change. So therefore, it is volume is 2 times pi integral 0 to a y squared dx. Again, trigonometric functions. So that is 2 pi integral. Go back to the same thing. X is equal to a sin t. So I'll change the limits blindly to 0 and pi over 2. Dx equal to a cos t dt. Y equal to a sin 2t, which I'll write as 2a sin t cos t. And then dy squared is equal to 4a squared sin squared t cos squared t. So I get 4a squared sin squared t cos squared t times a cos t dt. So I can remove 8 pi a cube integral 0 to pi over 2 sin square t cos cube t dt. That's the reason why we don't do areas and volumes, even though textbooks do in the beginning and later on in the end. I prefer doing the whole of integration and then doing volumes in the end, because then I can go over all the methods of integration. Right, I prefer this way, but if you, I don't know how your textbooks do it. This has an odd and an even power. Remember, at least one odd power. Split the smallest odd power into one and an even power. So it becomes 8 pi a cube integral 0 to pi over 2 sin square t cos square t and cos t dt. That becomes 8 pi a cube integral 0 to pi over 2 sin square t times 1 minus sin square t times cos t dt. When I differentiate a sine, I get a cos. So u equal to sin t, du equal to cos t dt, then t equal to 0, u equal to 0, t equal to pi over 2, u equal to 1. So that becomes integral 0 to 1 I can 8 pi a cube is outside. It becomes u squared times 1 minus u squared du. That is 8 pi a cube. Look, we're at the end of integration, so I expect you to be clever enough to straight away get the answer. U cube over 3 minus u power 5 over 5 between 0 and 1. So that's 8 pi a cube times 1/3 minus 1/5, which is 16 pi a cube over 15 would be the volume of the hourglass in terms of A. Of course, when you want to construct it, they had a concept, I understand over years they learned that the longest day is in June. And then the average was about 12 hours. So therefore what they did was they estimated how long it takes for each one of them and throughout the day how many times they had to do it, and then they knew the volume of sand, how much they had to put. Must have been so clever. You see, these days it's so easy. Imagine you're looking at somewhere in 1700s or even earlier. They had a concept of time. They had these hourglasses. But the precision in dropping the sand, exactly 1 hour or half an hour. I understand they had something which had minutes as well. Human brain, I tell you. You have it, I have it, everyone has it. It's only we have to know how to exploit it. Do you know that we only use about, we use only about 10 to 12% of our brains, I understand, or maybe, I don't know, I could be wrong. But I believe we are not using our brain to full capacity. Anyway, that finishes integration. See, I have done about 4 or 5 lessons on only questions on integration, and volumes I've done about 8 to 9 lessons, and apart from that we've done about 6 lessons on integration. So I got over 30 lessons where I've gone through the whole of integration. And remember, when you do integration, you revise trigonometry, you revise algebra, you revise differentiation and curve sketching. So that's why I had to spend more time here. So that's the reason why I did integration towards the end after I did everything else. So I only have one more topic left, which is differential equations, which I'll take it up in the next lesson. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.